Okay, getting ready 13. We're starting out looking at some arithmetic sequences, and we're to identify the constant difference and then write both recursive and explicit equations. So, constant difference is what we usually call that constant rate of change. What is the pattern here? So we see it's adding 5, from 8 to 13 adds 5, from 13 adds 5. Okay, so our constant difference is positive 5. We can complete the table with the next three values. That would be add 5 more is 28, add another 5 is 33, one more time is 38. Recursive equation. Now remember, recursive equation has two parts. We first need to give ourselves something to start with. So f of 1 is, the first term is 3. And then we always write our f of x is equal to f of x minus 1 and identify what is happening to get the next term, and it's add 5. You need both of those parts in order to have a complete recursive equation. The explicit equation will have to take the form y equals mx plus b, where m is your constant difference and b is the 0th term. So it will not show up in your little list of terms in the boxes. We're going to have to go backwards one place. So in this case, that will be y equals, our constant difference is 5 times x, but to add on the y-intercept, the b term here, we need to take our pattern back one space. So if I go backwards 5, I'm at negative 2. Let's do that all again at number 2. This time our constant difference, we see these values decreasing. It goes down 2, down 2. So our constant difference is negative 2. If we continue that pattern, 3 minus 2 is 1, minus another 2 is negative 1, minus another 2 is negative 3. Our recursive equation, we start out f of 1 is 11, and our f of x will be f of x minus 1 subtract 2. For our explicit equation, we can do y equals or f of x equals, it doesn't matter. The constant difference is negative 2 times x. Now the 0th term, I need to go backwards in my pattern as if we had one more box before the 11. So if our pattern going forward is subtracting 2, to go backwards we need to add 2 and have 13. So negative 2x plus 13. And number 3. This one is going down. The numbers are getting smaller, so I know I'm subtracting or adding a negative. From 3 to 1.5 goes down 1.5. From 1.5 down to 0 goes down 1.5. So our constant difference is negative 1.5. To continue this pattern, from negative 3, subtract another 1.5 is negative 4.5. Do it again, negative 6. Do it again, negative 7.5. Our recursive equation, we start off with f of 1 equal to 3, and then each f of x value will be the previous value, f of x minus 1, minus 1.5. For our explicit equation, f of x, or y equals, negative 1.5 x. Now let's go find our 0th term. If we take this pattern backwards one place, that means we're adding on 1.5. We're at 4.5. So our equation is negative 1.5x plus 4.5. Okay, now we have some patterns given to us in different ways, a list, a table, an explanation, and this time they are geometric. So geometric sequences means we have a common ratio or a multiplier And when we write our explicit equations, they take the form y equals a times b to the x, where a is that y-intercept, or that 0th term, and b is the multiplier, or the common ratio. So 2, 4, 8, 16, it's multiplying by 2. If it's not something that you can see obviously at first glance, what you do is start at the back of the pattern and try going backwards with division. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. And that will identify the common ratio for you. Okay? So we need to write our two equations. So our recursive equation, we would say f of 1 is 2, and each new f of x will be the previous value, f of x minus 1, times 2. That can also be written as 2 times f of x minus 1. So your choice. The explicit equation, f of x equals, now we don't have our 0th term, our y-intercept yet, so we need to take our pattern backwards one place. Rather than multiplying by 2, since we're going backwards, we'll divide by 2, it's 1. So 1 times, multiplier is 2 to the x. This 1 doesn't actually have to be written here. You could write f of x equals just 2 to the x. Okay, number 5. Now it's presented to us in table form, so it's like we do have two variables, an x and a y. This would be your x's, this would be your y's. We're looking here, we have the same pattern as we did in number 4. It's multiplying by 2, multiplying by 2, multiplying by 2. So I'm going to go ahead right now and jump backwards in my pattern and find my 0th. So if we had been multiplying by 2, to go backwards, I need to divide by 2. So 3 divided by 2 puts us at 1.5. All right, time for recursive. F of, now you can give me f of 1, you can give me f of 0. I usually just present the first one that was given to me. So in the table, the first value was f of 1 is 3. And then my formula, f of x equals f of x minus 1 times 2. The explicit equation would be f of x equals 0th term, 1.5, times the multiplier 2 to the x. Number 6, Claire has $300 in an account. She decides she's going to take out half the money at the end of each month. So I would start this one by making a little list so you can see the numbers as they change. So we start off with 300. She decides she's going to take out half at the end of each month. So half of 300 is 150. She's left with 150. She takes out half of that at the end of the next month. That's 75. Takes out half of that. She's at 3750. And so on and so on into the future. So we have to make a decision whether that 300 counts as our first term or our 0th. Since that's how much she has before any withdrawals, I would consider that the 0th term and then 150 to be the first. So our recursive then, I would say f of 0 is 300, and each f of x would result from f of x minus 1 times 1/2. My explicit would be f of x equals 0th term, 300, times 1/2 to the x. Number 7, Tanya creates a chain letter, sends it to 4 friends. Each friend is then instructed to send it to 4 of their friends, and so forth. So Again, we kind of have to make our own decision as to what counts as the 0th or first term. I would say that the 0th term should be Tanya. So she has the letter. That's only one person with the letter. The first passing on of the chain letter gets it to 4 friends. The second time it's passed on, each of them send it to 4 friends, so that would be 16. The third time it's passed on, 64, and so on and so forth. So I'm going to consider the 0th term, the y-intercept, to be 1, which was just Tanya when she was the only one with the letter. So my recursive formula would be f of 0 equals 1, and f of x is the result of the previous term, f of x minus 1, times 4. The explicit formula will be f of x equals 1 times 4 to the x. All right, number 8, we have a little picture here. So I'm going to need to count up those little plus signs. So on day 1, there are 6 of them. On day 2, there are 12 of them. And on day 3, that little rectangular array is 3 by 8, so that's 24. So we can see the pattern is multiplying by 2. Had there been a day 0, it would have had to start with 3 plus signs. So our recursive formula, we would start with f of 1 equals 6. F of x is equal to f of x minus 1. And then to get the next term, I'm multiplying by 2. For the explicit formula, we would say f of x is equal to our day 0, which was 3, times the multiplier, the common ratio is 2, and then raised to the x power. Okay, number 9, now we don't know whether we're looking at arithmetic or geometric, so we have to decide that first, then make both formulas. So, number 9, if you do not notice right away what type of pattern you're looking at, try starting from the back and doing the opposite of what you consider each sequence. So, example, to check for an arithmetic sequence, I would start at the back with 8, and I would subtract. So 8 minus 6 is 2. 6 minus 4 is 2, and 4 minus 2 is 2. Therefore, since I got the same answer, the same difference, that is our common difference, making it an arithmetic sequence. So number 9 is arithmetic. We would make our recursive with f of 1 equals 2, the first term, and f of x is equal to f of x minus 1, and then getting the next term is add 2. All right, our explicit, again, has to be y equals mx plus b form. So f of x equals the common difference, 2, times x, and then we need our 0th. So if we go backwards one place in this pattern, if we subtract 2 instead of add 2, we'd be at 0. So you can write plus 0, but you certainly don't need to. Number 10. So we look at this pattern. I see from 3 to 7 goes up 4, from 7 to 11 is up 4, and to get 11 to 15 is up 4. So this is another arithmetic sequence. It's adding, has a common difference. So f of 1 is 3, and f of x is the result of f of x minus 1 plus 4. Our explicit formula is f of x equals common difference, 4 times x, and we need to go backwards in our pattern to the day 0. Well, to get day 0, I would need to subtract 4 from day 1, so that puts me at negative 1, 4x minus 1. Number 11. It's increasing from 5 to 8 goes up 3, but 8 to 12.8 does not go up 3. So it's definitely not arithmetic. To try for geometric, again, start from the back. You know it has to multiply, so if you start from the back, the division, 20.48 divided by 12.8 is, I believe that's 1.6. No, I'm sorry. 20.48 divided by 12.8. Yes, 1.6. Okay. And then 12.8 divided by 8 is also 1.6. And then 8 divided by 5 is also 1.6. What that tells me, getting the same answer, is it is geometric, and I know that this 1.6 is my common ratio. So that's not one I would have expected you to notice in your head, but take a calculator, try the division, 1.6. All right, so our recursive formula, start with f of 1 equals 5, and then say each f of x is the result of f of x minus 1 times 1.6. For our explicit formula, again, for geometric, that means it's an exponential function. F of x equals 0th term. Now, to get our day 0 here, rather than multiplying by 1.6, we're going backwards. We have to do 5 divided by 1.6. So that would give me 3.125 cells. So day 0 is 3.125. And then our multiplier, 1.6 to the x. All right, number 12. Michelle likes chocolate but thinks it causes acne. She chooses to limit herself to 3 pieces of chocolate every 5 days. So I would try making yourself a little table here with days and chocolates. So on day 0, she would have no chocolate. She has had no chocolate. Every 5 days, so by day 5, she has had 3 chocolates. By day 10, she has now had 6 chocolates. By day 15, she has now had 9 chocolates. Now, the rate of change is not 3. It's 3 every 5 days. So if we think back to our delta y over delta x, every time the chocolates go up 3, the days go up 5. So our constant difference, or common difference, is actually 3/5. So that makes this one an arithmetic sequence. We can start our recursive with f of 0 is equal to 0, and f of x is equal to f of x minus 1 plus 3/5. Our explicit formula in slope-intercept form, f of x equals 3/5 x, and then the 0th term is 0. You can write plus 0 or just leave that off completely. All right, 13. Scott decides to add running to his exercise routine and runs a total of 1 mile his first week. He plans to double the number each week. So again, you might want to look at a little table, but hopefully the word double has given away that this is a geometric sequence. To double something means we're going to multiply by 2. So he runs a total of 1 mile his first week. So week 1, 1 mile. Week 2, he's going to double that 1 and have 2 miles. Week 3, he's doubling that amount to 4. Week 4 to 8, and so forth. Again, I'm going to need week 0, so let's go ahead right now and find for week 0, I need to go backwards, which would mean rather than multiply by 2, I'll divide by 2. Well, 1 divided by 2 is 1/2. So our recursive formula, start with f of 1 equals 1. And each new f of x is found by taking the previous term, f of x minus 1, and multiplying it by 2. The explicit formula, and since it is geometric, that means an exponential equation, f of x equals 0th term, 1/2, times the multiplier, 2, to the x power. 14. Vanessa has $60 to spend on rides. Each ride is $4. So, once again, we start off when she has gone on no rides. She has $60. She goes on one ride. She spends $4. She now has $56. 2 rides, she has $52. 3 rides, she has $48, and so on. So this is decreasing $4 at a time, $4 for each ride. That makes it arithmetic. That means I can write my recursive formula, f of 0 equals 60, f of x equals f of x minus 1, and then subtract 4. The explicit formula, since it's arithmetic, has to be y equals mx plus b. F of x equals the constant rate of change, or common difference, -4, times x, plus the 0th term, which we already have was 60. All right, number 15. Adela bought a car for $10,000. 1 year later, it was worth $8,000. So let's see. When it was, we're looking at the age of the car and its value. When it was brand new, it was worth $10,000. After 1 year, it was worth $8,000. A year after that, it was worth $6,400. The next year, it was worth $5,120. So I think we can see right away that this is not arithmetic. It must be geometric. So let's look for our common ratio. Well, all we really need to do is start at the back and divide. 5120 divided by 6,400 is 0.8. So this means we're really multiplying by 0.8. So it's multiplying by 0.8, 0.8. So our recursive equation, f of 0 equals 10,000. Each f of x comes from taking the prior term and multiplying by 0.8. The explicit must be an exponential equation. F of x equals starting amount, $10,000, times the multiplier, 0.8, raised to the x power. Okay, Cami invested $6,000 into an account that earns 10% interest. Now, anything with percentage growth or decrease, we've talked about being an exponential function. That means it's geometric. So if we earn 10% interest, okay, so, and that's each year. So we're going to have years, and we're going to look at the value of her account. So at year 0, when she starts her account, she puts $6,000 in. She earns 10% interest, so you don't multiply by 0.10, but by 1.10, all right? She's keeping 100% of her original investment and adds 10% more, so 100% plus 10% is 110%. Turning any percent into a decimal, we just move the decimal point 2 places to the left, so our multiplier is 1.1. So we're going to multiply by 1.1. 6,000 times 1.1 means she has, after 1 year, $6,600. Multiply that by 1.1. She will have, after 2 years, 7,260. One more time, times 1.1. After 3 years, she now has 7,986. So again, it is geometric. We are multiplying. So our recursive formula begins with f of 0 equals 6,000. And then f of x is f of x minus 1 times 1 and 1/10. And finally, our explicit formula for that one would be f of x equals our original investment, $6,000, times our multiplier, 1 and 1/10, to the x.